Hello AP Chemistry and welcome to video number 4 covering electrolytic cells. So these are different than galvanic cells, right? And if we look at this picture, what key thing stands out as making this cell different from the other ones? Right. We have a voltage source, right? Meaning that no longer is this cell generating a voltage that we measure and can then use to power something else, right? This cell, we have a power source, right, that provides a flow of electrons, right, that powers a non-spontaneous reaction, okay? So the whole point of an electrolytic cell that instead of using it to get power, right, we are providing power to get some desired reaction out of it, right? So if we look here, right, in this case, right, we have molten NaCl. What does molten mean? Right, molten means melted, right? Meaning that there is no water present here, right? We have heated this up to like, I don't know, 700 or 800 degrees Celsius, I forget where it melts, until my NaCl is molten, right? Then we have anodes and cathodes in here that can withstand that kind of temperature, right? And a power source that's going to push electrons here, right? And basically attract electrons here so that we can get this reaction to happen, right? Where we're going to get some liquefied sodium and some gaseous Cl2, right? Note that if there were water present, this reaction would be moot because the sodium would immediately react with the water, which is why it has to happen when it's molten, right? So here are our reactions, right? Chlorine negative to chlorine gas. Let's see what that energy is, right? Chlorine negative to chlorine gas. If we look here, right, that energy is going to be negative 1.36, right? So negative 1.36 volts, right? Sodium plus to sodium liquid, right? Sodium plus, we're going to use this as a good approximation, is negative 2.71. Negative 2.71. Which means, sorry, that the overall voltage for this is decidedly negative. Yes? Does that make sense? Right? Decidedly negative. And just to add them up, which means that in order for this to happen, right, we need to have a voltage source that meets at least 4.07 volts. Okay? So kind of like in the previous ones where we could measure a voltage that comes out, here, right, this number basically tells us how much power we need to put in to make this happen, which means that if I had a power source that was like 1.5 volts, which is like your standard AA battery, if I had a 1.5 volt power source, we could not make this reaction happen, okay? It needs to be at least 4.07 volts or greater if we want this to occur, all right? Next up, one of the common reasons for using electrolytic cells, again, we have a voltage source, and that's always going to be your key ding, ding, ding that tells you you're looking at an electrolytic cell, which by extension, right, all electrolytic cells will have negative voltage values, okay? So the opposite of galvanics. So here, right, we understand, right, because we just saw one of these, right, if we have a cell that is set up where nickel is both our electrode and our ions here, right? Basically what we're looking at here is a E0 of 0, right? Now, thinking back to that last problem with the Nernst equation, right? Yes, we could skew the concentrations to make this reaction happen in two separate half cells. Or we could put up a voltage source and force this reaction to occur and force nickel to basically deposit, right? Force it to be reduced and then deposit on whatever object here is conducting the electrons, right? So this electroplating, right, is how we get a lot of our plated jewelry and other items for your house and things like that, right? Wherein we put it in a solution and we force a current through it and we get something to plate on the object. Yeah? Okay. Now, a quick practice exercise. So, and note again, right, one of the things to think about here, if we're solving for our half reactions, which we didn't do here, but if we were, it's the same idea, right, where we would look at all of our options for our half reactions, except now we are looking for our voltage to be negative, okay? We want a negative voltage, and preferably one that is underneath whatever the power source is, okay? Now, if we have a power source where we don't know what the voltage is, the most likely reactions are going to be the one with the lower voltages, okay? Because those are the ones that are going to happen first, right? All right, going to a practice problem. So we have a half reaction for the formation of magnesium metal upon electrolysis of molten MgCl2 is this, right? So here's our pertinent reaction. We're going to make some solid magnesium. We want to calculate the mass of magnesium formed upon passage of a current of 60 amps for a period of 4 times 10 to the third seconds. Okay, here really, really important to talk about what an amp is, right? So those of you in physics might be familiar with it, but an amp is coulombs per second, okay? Amps are coulombs per second, and as long as we know that, this just becomes a stoichiometry problem, okay? Wherein I know that if I have 60 amps, right, that's 60 coulombs per second, right? And then I know that we are running our cell for 4 times 10 to the third seconds, right? Cross that out. Now, do we know of some constant that we could throw in here that would be useful that has to do with coulombs? Right. Faraday's constant, right? That's the number of coulombs per mole of electrons. Now, over here, how many moles of electrons are being exchanged? Right. They even told us that, right? So 2 moles of electrons, and if not, we could figure it out, right? We can figure out how many electrons are needed for magnesium's reduction. So there are 2 moles of magnesium for every, thinking back to my question, I want to know about magnesium metal, 2 moles of electrons for every 1 mole of magnesium metal, right? And I know that 1 mole of magnesium metal has a mass of 24.31 grams. Yes? And that's how I solve for the mass of magnesium formed at 60 amps for 4 times 10 to the third seconds. Okay? And the other one is basically the same problem backwards, yes? Where I have a number of grams, I have my number of amps, and I want to figure out how many seconds we're talking about, yes? All right. Okay. So that's electrolytic cells. Make sure that you understand this math. And obviously, in terms of recognizing one from the other, right? Sometimes it'll say, right? Or sometimes it'll say that we're talking about an electrolytic cell. Here, electrolysis is a key word for electrolytic cell. Okay. And it says that we're passing a current, which means that we are supplying power, which is different again than the last few problems that we did in the last set of videos. Okay. All right. Thank you for listening. Be good, and I will see you soon. Bye.